So this afternoon, we're going to be talking mainly about building the base year scenario and then also getting into creating application scenarios. So we want to go through the base year development process, the model validation, then we'll get into creating some scenario applications. Okay, so our first task will be to configure our transit system base year configuration. So there are 6 general steps here, and the objective of the validation is to fit the T-best observed T-best ridership estimation from the base year scenario to actual observed ridership. So to set that up, we have to do all these steps we've been kind of talking about, where we're defining the base conditions, setting the socioeconomic growth, and then finally entering observed ridership that would be at the route level, and then running the T-best ridership estimation model and configuring the validation. So we're going to be walking through each one of these steps. There's some details here that we're going to go over in the subsequent slides, but as an overview, this kind of serves to guide you on the overall steps to perform your model validation. So what is a T-best base scenario? The base year scenario represents the known transit service, socioeconomic, and performance conditions. The base year scenario is used as an input to the model validation. After validation, the base year scenario is set as read-only. So in our example that we have over on the right, we have our Gatorville transit system. We have our April 2025 is the base scenario. It's set to read-only, and that's after validation. That means you can't edit it. You can open it, you can look at it, but you can't edit it. In order to create new scenarios, you make a copy of this scenario, and then you kind of work off of that to create alternatives. So it is a read-only scenario after validation. In Florida, we have the transit system downloads have one scenario, which should be utilized to develop the target base conditions for validation. Outside of Florida, you need to create a network scenario to begin building the base conditions. So this is pre-done for you in Florida for the most part. You'll need to do some updates, which we're going to walk through as part of this section, at least, the type of updates you would do. And then, so to help you kind of along in the process. All right. All right, so just looking at the properties, so the base scenario properties. So what you're seeing on the right are just the network scenario properties where the name is April 2025. It's set to the scenario model is the T-best land use model 5.0. You enter a description, which is not optional. One of the most important parts of this, and I think this actually came up as an earlier question, is how do you set the forecast year, right? So this forecast year is right here, right? So that is where you set it, scenario forecast year. So whatever out year that whether it's your base setup, which in this case, we are setting up the base year, so it's 2025, matches our April 2025 GTFS. So our forecast year is 2025. If we were going out into the future 10 years, it would be 2035. So this is where you set it, and it's an important piece of the overall puzzle, especially as it relates to socioeconomic growth. The mean annual wage is another element. So this element is the mean annual wage. Essentially, that comes from generally from the Bureau of Labor Statistics. So this lookup link will take you to the Bureau of Labor Statistics. We have basically an interface, or same as we have with the census. There's an API that we can go get the mean annual wage dynamically from them for any county in the US. So you would just navigate that to find your county and look up your mean annual wage. Now, the mean annual wage is used in the T-best model as a value of time. So essentially, and money, right? So essentially, as you are using fare within the model and wait times are also kind of attached to this, that basically you're saying that the higher the wage, the less valuable fare is to you, meaning, you're willing to pay more. The lower the wage, you have less money to spend on fare. So it's just a measure of wages in the area and ability to kind of pay for the fare component. Okay, so We have an annualized growth rate. So if you want to expand the mean annual wage out into the future, you put in an annualized growth rate, a compound growth rate that would take it out however many out years the forecast year is to kind of keep up with inflation. The socioeconomic input. So basically the employment data, the default block level data, that's fine. It's going to be the default, and then the parcels will generally always be the default. We'll talk about the parcel scenario part later on, but certainly for the base year, we're just using the default parcels. Okay, so the next component of this is socioeconomic growth. And so to think about this, we have to, kind of define our SE data again, right? For the transit system, we have our block Census 2020 block demographics, 2023 ACS 5-year block group demographics, our employment data, which is actually the 2022 LEHD, and then land use data for the 2024 population. So there are a couple of components of this. One is that if you're going to use TAZ data as your source for socioeconomic growth, so just to define what TAZ data is, it's your transportation analysis zones that generally correspond to your TPO, your MPO, what they were required to do to create socioeconomic forecasts to support the travel demand models in your region. So, so you can use those data sources, even though someone mentioned they go out 30 years, of course, then they do, but you can still use them in TBEST because we just want to capture generally the compound growth rate that goes along with them relative to our source year. So in order to start out, though, we have two kind of mechanics here going on. One is relative to the base year. So this the center option in this growth rate profile is to sync the transit system SE data with the MPO zonal base year, so that essentially the TBEST base year becomes the same as the MPO base year, because you're basically using the MPO zonal data as a control totals at the zone level, and then using that to update the transit system SE data so they match on a zonal level. So this is important because if you're going to use the forecasted TAZs for the future, they need to be in sync with the base. So if you're going to use TAZs, you don't actually have to use TAZs. You have a system-wide growth rate that you can apply. That's obviously a very generalized growth rate. But if you're building TBEST for a TDP, it's recommended that you use the transit system SE data and then sync it first, and then you apply on the scenario level your zonal future year projections, so that you have the base data lined up with TBEST, and then you have your future year lined up with TBEST. So that is what this is helping you do, and there's tools to help you do this. All right. So the sync part is basically a setup where you're referencing, annotate here a little bit, you're referencing the TAZ zonal data set containing the base year socioeconomic data. So in this case, it's referencing a zone data 15. The TAZ base year is 2015. And then what you do is for all of the TBEST attributes, or the socioeconomic variables in TBEST, you look for the total population value from the TAZ data set. So this lookup button will look up all the field names in this shapefile, this zone data shapefile, and you find the one that matches total population, that is for the base. And you do that for the household variables, employment, and income. Now, you don't have to do all of them. You really, primarily what people do is they do population, household, employment totals. And then sometimes they'll do some of the demographics, but generally if they don't have them in the TAZ data, they don't use them. So those are optional, right? So primarily what's required the only one that's required is total population. The others are optional. Household, employment, income are optional. All the demographics are optional. So just keep that in mind. It tries to match up what you have available in your TAZ data set, and then you do as good a job as you can matching up to the TBEST attributes. Note that this can be an ArcGIS online, a local geodata set or an ArcGIS online data set. So if you have your TAZs in ArcGIS Online, you could reference that right here, and it will bring that data set in. We did that for the links setup in Orlando, where the Metroplan had their TAZs in ArcGIS Online, and we didn't even have a local copy. We just would pull them, reference the ArcGIS Online layer here, and it would just grab it and pull it in and create these, the growth, or do the syncing here. Okay, what else do we want to say here? Ensures that T-best scenario associated growth rates are consistent with TAZ growth. That's right. So the consistent part is what we want. Performed before validation, usually after transit system is created or after updated socioeconomic data package data has been imported into a transit system. So this is pre-validation that we're doing this. Okay. All right. So the other option we had, and this is for the parcel, I'm sorry, the at the network scenario level. So we did the other one at the syncing at the transit system level. This is on a per scenario basis that you can set the socioeconomic growth rates that would go out into the future. So obviously, if you have alternative scenarios, their growth might change. Some you might want to have high growth, some low growth. So you, on a per scenario or application scenario basis, you can change the growth. So that's what this is doing. And what this is setting up is that you have a general growth rate that you can add. So this is like a just system-wide growth. And these are compound growth rates that, in this case, 2% is the population growth rate, 1% for employment in households, and others for income. And so you also have this link, population growth rate reference table. So this comes from Bieber, which is a Florida research group that does projections of population and employment to the future. So this references this table, which is a per county basis for Florida, at going out to 2050, the low, medium, and high forecasts for population growth. So you can use this lookup to fill in these values for population, et cetera, right? And based on what you would want, high, medium, or low growth rates, it may depend on, what you're trying to model, right? So all of that is kind of a part of this. All right, so you also have this option to set the zonal growth rates. So if you check this button, we will go to the next slide. So when we checked it, now we have this zonal annual growth rates, where basically it's a very similar setup to the sync, where we just reference a shapefile or an ArcGIS online data set. This time we're setting the projection year. So our zonal data, our TAZ data set is 2045. And remember, this is at the individual network scenario, application scenario level. So we can have various growth rates across scenarios. So so this one is showing total population set to TOPOP 45. That's the value in the shapefile that refers to the population in 2045. So you're really just doing the same matching that you did before. This time you're doing it for out years instead of base year. And when you're ready, you hit set growth rates, and it will calculate compound growth rates for all of the using the TAZ data, so that can be applied to any out year. Right. So if you're, 10 years, 5 years, whatever it is, it will apply that out for how many years your scenario, your application scenario. Okay. All right. So once we have our growth set, right? So remember what we're doing here. We're configuring the base year. We're making sure that it's up to date. And we're also setting growth rates. So we're digging in and we're building up our base year conditions. So part of that is going to be through the GTFS import. So we want to grab our base year information, our base year GTFS, the most recent probably, where you have observed route level ridership data. So that's kind of the key piece here for validation purposes, is that you need to have observed ridership. So it may not be what's on the ground right now that you're capturing, because you may not have ridership data yet compiled for what's on the ground. You may have to go back a little bit to get in time to get a GTFS where you have observed ridership in full to input into the validation. So the example here is Broward County Transit or BCT, where they're working on their T-best base year for the ongoing TDP. The available BCT transit system download contains the spring 2024 service. However, BCT has September 2024 GTFS, and the corresponding observed ridership data is available. So in this situation, BCT would update the default network to September 2024. So essentially, that's what we're going to be doing in our next exercise. Is we have more recent data than what's in the default that you would download from Florida for Florida, and then we're going to update it. All right, so the next item is fare levels. And for Florida, when you download a transit system, it will have a base fare and transfer fare that were accessible basically from the websites of the individual transit agencies. So we just collected that information, went to the websites and got that information and populated. However, it may be incorrect. There may have been fare changes since spring 2024 that you want to change. So part of this is just evaluating what's in that transit system, looking at the fares, and then inputting what's actually current. So in this case, we have a base fare for right here that's set for radial, crosstown, and circulator, right? So that's the only route types. There are no other modes of the premium modes in this transit system. All we have are radial, crosstown, and circulator. So we don't actually need to input any of the others, and there is no transfer fare. So essentially we have a cash fare, a base fare that we're inputting here, and that's pretty much it. We can implement fare exceptions. So if there is an exception for one of the routes or more routes, you can implement them as a fare exception. You have an inflation rate as well, again, relative to what out year you might have, an inflation rate for the base fare or transfer fare values. I will say that, obviously cash fare isn't necessarily representative of the revenue relative to fare, because there are so many discounts available. And in a place like Gainesville, where you have the student fare subsidized by the university, then there aren't receiving any cash fares for those student riders. So it could be that you input a average fare per rider here that you would have calculated rather than the base fare. And that might be more representative of what's actually happening when people board the bus than the actual cash fare. And that plays out in, when you're running the model, the sensitivity to fare, right? So just keep that in mind as you're doing configuring it, that is a possibility to put in average fare per rider. All right, so another kind of tool here that we have to update our settings is using the route operations settings. And so essentially this is a calculator for the routes. And to calculate the route settings, meaning the route type, the technologies, you can update a route name prefix, the route color. So here's the prefix. So if you want to add or remove a prefix from a route to separate it out. And this is handy, we haven't really mentioned this, but with your GTFS import tool, you're not limited to just your agency. You can import routes from any agency that might be servicing in your service area and connecting to your service. So certainly in the modeling part of this, the ridership estimation, if you're connecting to other services and you're seeing ridership because of it, then you want to include those routes that might be operating in by other providers in your network. So one of the ways that we distinguish between a Route 1 from your system versus another system is to add a prefix to that, to one that might be outside of yours, such as, if you're a Broward County Transit and you have a Miami-Dade route that you're connecting with, you might put MDT here as a prefix and add it to all the MDT routes so you can visually see and also, query those out if you need to. Okay, so you can also add route color. Vehicle seats are also updatable at the route level. Set the minimum route layer on a route level basis. And these are whatever you would select, routes you would select in the routes panel that you can update. The fare, so you can change and basically set fare exceptions here at the route level. Interlined routes, annual service days, and operating cost all can be updated for the routes by changing the value here, hitting update, and it updates in the routes panel. Okay, the other item that we need to take a look at when we're updating our base year configuration is special generators and amenities. Now, these have multiple reasons to do this, and they're related to both the modeling and ridership estimation, which kind of serves as the special generators part of this, where there is some sensitivity to setting a shopping mall at a stop or a university at a stop, because there is some extra demand there for ridership. And basically, it's a what's called a dummy variable in the model to escalate ridership at that stop because it has that characteristic. So that's really what a special generator is. Now, we also have the ability to add amenities, right? So amenities are more like shelters and signs and things like that aren't really special generators. They're just what you would have on the ground that would be at that stop. So all of those can be added to at the stop level and generally added for the purpose of modeling and for querying and for creating maps, right? So these are integral in actually creating maps for Title VI. They're very handy to have for the query tool, where we can query all the routes at shopping malls that have certain levels of service. So there's all kinds of ways that you can use this. And also, once you have them input, they stay with the network, right? So basically they continue on and stay with the network, and then are perpetuated with TBEST. So just keep that in mind. This is the calculator where you can select multiple stops and then calculate the value for multiple stops. So if you wanted one stop to have both a bench and a bike rack, you could select that and hit the update button, and it would add those values to the special generators for the selected stops. Okay, so let's do an exercise. So this one is takes a little bit of time to complete. We're going to go through a lot of what we just talked about with socioeconomic growth, doing some updates of settings, setting some special generators, all in the process of building our base year configuration. So these are our existing conditions that we want to get our scenario to, so we can get everything the way we want it before we validate. So existing conditions. All right. So if you want to join the breakout room, the TBEST exercise breakout room, and then work on this on your own without narration, Sam will be over there to provide technical support and any help that you might need in getting through the steps. And then I will narrate here and go through all the steps with you as well. So with that, are there any questions that we have? So
Yes, we have a couple questions.
okay, so let me find that. Okay. Okay, can fare be set by zones? And the answer to that is not really, no. Generally, it's just by first boarding and transfer boarding, and you know, and it can't be set at the stop level. That would be handy if you could set fare at the stop level, then you could maybe do by zones, but or it's something similar to that. But what I would say is, if you do have zones, you can always take the average, look at even your average fare per rider on that route, and do something like that, where it takes into account the actual distance that people are traveling on that route, and do an average fare per rider. That would be my suggestion. Okay, the next question, I didn't catch all the details pertaining to fares, so apologies if you addressed this, but, oh, sorry, our zone-based fares supported, I just gave that answer. Okay. Okay, with that, we will start into our exercise. Okay. Okay, I am on part one of base year configuration, transit system operation and policy settings. So in TBES Explorer, right click on the Gatorville transit system and open the operation and policy settings. So I'll just collapse some of these. Right click on Gatorville, go to the operations and policy settings. And then we would just want to define the service area as just Alachua County. So we uncheck Columbia, Gilchrist, and Libby. And note that you can define the service area using a mobility area. We talked about that a little bit earlier with links. So, but right now for Alachua County, we're just going to select Alachua, or sorry, for Gainesville, Alachua County. And it says review other properties to make sure they are consistent with the transit system operating policy. So as you're doing this for real and you're working with this, you might use the service, grab the actual current cost parameters and add these to the default operating cost, either per hour or service mile, service hour, service mile, or a split cost formula. Look at any seat capacities, check on your Title VI income levels and Title VI policy parameters, etc. Make sure everything is valid here, and when we're ready to move on, just say okay. All right. All right, part two, verify the Gatorville Transit System properties. Okay, so with this, we will right click on Gatorville Transit System and select properties. Okay, so looks good. It's unvalidated. We have the block level LEHD, our employment, census, and parcels look right, and our extent is fine. Now, extent is different than service area, so just keep that in mind. The extent is basically where you can get to, meaning like the different counties that you might have service in. But service area is where you're going to define kind of Title VI characteristics when it asks for your service area population and your percent minority. It's really referring to your definition of the service area, not the service extent. So just to make that distinction. All right. So there is a note here. It says if the defined transit system county extent doesn't match the current transit system service extents or what will be proposed county extents, utilize the transit system socioeconomic updates import from TBES support socioeconomic data package tool to re-import the SE data. So what that's talking about is if we had updates to the SE data, let's say there's a Florida 2025 and we want to update to that, we would right click on this and go to socioeconomic updates, import from a package. We would have our Florida 2025 downloaded and we would just set OK and it would pull all the 2025 data in to our TBEST transit system. So that's what it's talking about. And then we could also expand it. So if we had other counties that we wanted to add, so let's say that we needed to add Bradford County to our extent, we could add it, say okay and hit okay here, and then it would expand the extents, right? So you can add counties to your extent using this tool. But we'll cancel this. We're not going to run through that. Okay. All right, so next is this is part three, verify the base scenario properties. So we're going to right click on our Gatorville Fall 2024 and go to the properties for it. So we have our Fall 2024, our TBES land use model 5.0, that looks good. 2024 is the forecast year of the mean annual wages set to 61,445. That looks good, 0%. We have our LEHD block level data and parcels set. All of this looks good to me. If you needed to update any of this, you can, of course. But for right now, we're going to leave it and we'll say, okay, we're just verifying. All right, next. Syncing transit system socioeconomic data with TAZ base year. All right. So we talked about this in the slides. So we're going to go to the Gatorville Transit System, go to socioeconomic data updates, and sync TAZ data with base year. All right, so we saw this form in our slides. So we're just going to fill it out and run through the syncing process. All right, so first of all, we need to have a TAZ data set. So we're going to use this lookup button, and we're going to go after a local mobile geodatabase or shapefile. In this case, it will be a shapefile. And we're going to need to navigate to the C, TBEST 5, Transit Systems, Gatorville, Data, TAZ. Then we have the Zone Data 15 shapefile. So Zone Data 15, it's a polygon type. We select it and we just say OK. It adds it as our reference, and we need to select the base year. So this is a very old base year, 2015, obviously, very old. So of course, it's the MPOs range, and I mean, generally, I think they're supposed to do it every 5 years, update the SC data, and the models may range from like 10 years. So in this case, they really haven't updated their TAZ data for 10 years. So they're due for a new one. So in this case, we're going to run through it. In reality, I would be, a little bit hesitant to use something so old. So just for your own edification, you use your judgment here on what makes the most sense. But in this case, we're going to run through this TAZ base year from 2015. Okay. So we want to look up our variables. So here's the reference columns, and we can select our value for total population, which is totpop 15. Here's totpop 15. Notice that it enabled the other demographic variables once you have selected this value. So if we wanted to, we could set individual demographic values, but for our demonstration and training, we won't do that. The other attribute we want to set is we want to go to employment. And we do have a total employment value for this, which is the tot EMP. So we've set that. So that's really it. We have our SE data set for our TAZs from 2015, our base years 2015 for the TAZs, and we have our employment and population, and that's it. That's really all we need. We hit sync data sets just to confirm what the inputs are and hit yes. So this is going to update the actual TBEST data to the control totals that are in this file, right? It's in the TAZ data, so that the population totals will match those in the TAZ, and the employment totals will match those in the TAZs. So there is some other matching that goes on. So basically the same growth rates that are applied for the population also get applied to the households, right? So it's because maybe you didn't have a household growth rate, or they should be pretty similar. Basically you're using what you have within the TAZ data to update your TBEST growth. Okay, so when it's done, it will say okay, and that's it. We can cancel out of this. One thing to note, if I go back and look at the properties for fall 2024, now my population source year is set back to 2015, as is the LEHD and the parcels. So it's going to be grown now from 2015 forward, right? Using the growth rates from the 2045. So it's going to grow it out, right? So you can see how it's needed to do that. But if you're setting it back so far, it may lose some of its value because you're going so far back in time. Okay, but that's our process. Obviously, you want to use the most up-to-date TAZ data that you have. Okay, so the next item is exercise part 5, set the base year socioeconomic growth rates. All right, so we're going to go right-click on fall 2024 and socioeconomic growth rates. And we're just going to set the total population to 1% growth rate. This is the annual compound growth rate. and employment to 1.5. Now, you could set households to another number and incomes to another number, but generally, we're just going to leave it at this for now. Okay, so these are the system-wide growth rates, right? So for every county, this is what will get applied unless it intersects with a zonal shapefile, right? So if the intersect of the TBEST census data intersects with this shapefile, or the TAZ shapefile, then it will use the TAZ growth rates instead. So, so that's what we're going to select here. All right. So again, we're going to use a local data from Mobile Geo database. This time we're going to select zone data 45. And our projection year will be 2045. And we're going to set the total population to tot-pop. 45. Did I miss it? Yes, there it is. 45. And then our employment will be tot employment. So that's it. So really employment referenced, population referenced to 45, projection year 45, 2045 shapefile for our TZ estimates. We just hit the set growth rates. Again, would be prompted, hit yes. Okay, great. Those have been updated too. All right, so our next task, this is part 6, is to set the system fares. So again, we'll right click on fall 2024 and go to our fare levels. And we're going to, instead of the base fare being $1, we're going to set it to $1.50. So 1.5, and I can just copy this and double click in here and paste it. So basically we're just updating the fare. You know, the fare had changed, let's say hypothetically here between the fall 2024, you know, what we know to be, and then we're going to update it to 1.5. So me being the agency coming in and updating this, I have a better idea of what the actual fare is than, you know, what we did when we first created it. So it's basically the agency giving better information to TBEST because they have it, and then they can set these values. Okay, so everything looks okay. Okay, notice you can set the fare exceptions. You can set the inflation rate if you want to. We'll just leave those at 0 for now. Great. Okay, so let's now go in and take a look at the network. So we're just going to open our fall 2024 network scenario. And in TBEST, okay, so we're opening it in the scenario network editor routes panel, review the operation settings for each of the listed routes. So what I want to do here to have a better view of this, I'm just going to expand this panel so I can see more of the routes panel. And if I wanted to, I can minimize the Explorer panel. All right, so we have a description, we have our route types. So we have type here is our route type. The technologies are all bus and cost and all that. So let's just confirm a few things. So within the routes panel, select the crosstown routes. So basically we see which ones are crosstown. So this is crosstown. We have additional crosstown. I'm just holding the control key down and selecting individual routes. So we have 4 total routes that are crosstown. And right click on the selected routes to open the update route operation settings. All right. So explore the route settings in this dialog. Explore the route settings edit options available for route type, technology, color, etc. Verify the following route type equal to crosstown, which it is, and $6.92 per service mile. So all of these are the correct values, so we're good with that. All right, on to the next. So this is part 7, exercise part 7, update route type and operational settings. So modify the route color for the selected crosstown routes to display as bright red. Okay, so we would just use our route color and do the lookup and select a bright red color and say okay. And notice when I do that, this button turns red, which means that in order to actually execute this change, you need to click this button. So when we click it, yes, I do want to change the settings, and you notice that those routes turn red. All right. All right. Okay. So the next step is keep the route operations settings dialog open, which you can do, and select all routes in the routes panel. So again, we use our Control A, we select all of them. And we want to update the value for vehicle seats. Right now it's set to 60 for all of them. So if we scroll over, you can see that they're all at 60 seats. And we want to set it to 55. So again, we'll change the value, hit the update button, and all the values will change over here in the routes panel. So essentially it's a calculator, right? So you're calculating values for the routes operation and policy settings. Okay, so let's close this and we can clear our selection. So we'll just clear the map selection and then we'll hit the save button. So we haven't hit the save button yet, but whatever changes that we make, it will enable the save button where it says save network scenario. So those changes that we just made to change it to 55 seats instead of 60, that needs to be saved. So we'll hit save. It'll say saving the network. And when it's done, it will disable the save button. Okay, the next task, and maybe we'll resize our routes panel back over to here. We can use the horizontal scroll bars to scroll it to the left. And just so we're kind of back to center here, we can see our list of routes. All right, so our next task, this is part 8, is to update special generators and amenities. So in the map display, zoom to the Oaks Mall. All right, so the Oaks Mall, you know, I'm sure some people are not familiar with where the Oaks Mall is. It is right here in, you can see it on the map, Oaks Mall. So if you're doing this yourself, it's in this area of Gainesville, out near 75. And this little loop here that comes into the mall and goes back out is the Oaks Mall. All right. So we're going to use on the stops panel, the view mode. So you can see where it says view all stops. So I'm hovering over it and I'm going to click it. So that shows all the stops in the network. So now we can see that there are stops at the Oaks Mall. Here is the stop location. So what we want to do is select them, right? So in order to select them on the map, we need to switch from our select routes on the map to select stops on the map. And now it automatically selects our features on the map so we can come in and select them. So we'll just drag a box. So I'm just going to drag a box around these stops just like this, and it will select them. You can see that it's a little bit hard to see, but there is a halo, a turquoise halo around it. It means they're selected. And you also see down in the stops panel, it says selected here, 2 of 2,437. That means that at that location, there were 2 stops that we need to update. Now, when we're talking about T-Best stops, it's stops on a per pattern basis, right? So there might only be 1 stop there as officially, like a bus stop, but you're going to have multiple patterns serving it, route patterns. So basically the 2 is how many patterns, the selected number 2 is how many patterns are there. All right, so what's next? So we want to switch the view mode now to selected stops only. So what we see is that we have 2 stops, and you notice that all the stops went away except for the 2 that we have selected. They're on Route 23 and 75, and both are stop name of 173. That makes sense. And what we want to do is use the calculator to calculate the stop values for the generators and amenities and set a value here to shopping mall. All right. So I am on part 8 now, step 7. I just clicked the calculate stop values button to open the dialog. I get the list of columns to update, which is over on the left. This is the columns to update. You see that stop name is here. I could update stop name, description, time point. But really what I want are generators and amenities. So I'm going to use this set a value option and this lookup to select the shopping mall option. So here's shopping mall, and I just hit update, and it will add shopping mall to this as the special generator at this stop. Now, notice that you can append to existing values. So if there are multiple generators or amenities here, you can have as many as you need to define what's actually at this stop. So you're not limited to one special generator or amenity. There can be multiples. You can also check this to remove any one that you want to remove or selection that you might have. So both are available to manage the stop level generators and amenities. Okay, so that's it. That's what we wanted to do. So I'm going to save this scenario. And basically in total, what we've done is we've downloaded the Gatorville transit system. We've looked at it. We've changed route types. We make sure they're all right. We looked at our fares to make sure they are right, populated any special generators that weren't populated. And of course, we did it in a condensed format. But when you're doing this, at your desk, you will be looking at your network to make sure that you have everything populated and everything looks correct before you proceed with validation. Okay, I think that's it for that exercise. We can keep going here. Everyone out of the breakout room, Sam? I guess they are.
Yes.
Okay.